Hi everyone. Today we're going to practice proportional reasoning using the question, how many parts compared to other parts? The potential answers to this question are best expressed using something called ratios, specifically part-to-part ratios. We will also explore ways you might use equivalent ratios to communicate your solutions more simply and clearly. Let's start by trying an example together. Today, it's going to be all about the bingo chips. If we're going to tackle the question, how many parts compared to the other parts, the first step is to do a little counting. In this example, there are two different parts to this set, purple parts and orange parts. How many of each? Pause and find out. After a little rearranging, it's clear that we have 4 orange chips in this set and exactly 16 purple chips. Like with fractions, ratios have 2 tidy little options for expressing each part in the set. The first option looks like this. You can see the 4 and 16 separated by a colon. Or like this. You basically do the same thing but use the word 2 instead of the colon. There. Very nice. And just like with fractions, you must develop the habit of simplifying your ratios. Time for an equivalent ratio in lowest terms. Let's take a look, shall we? This is where the purpose of a ratio becomes a little bit more clear. Basically, we are looking to see if there's a relationship between the two parts of the set. With a little fiddling, I can see that for every 1 orange chip on the table, I have 4 purple ones. And as long as this relationship holds for all of the chips in my set, and it does seem to be the case, then I've found the equivalent ratio. You can also find the equivalent ratio using a little bit of math. Let's take a look here. First, I have to think of how many groups to divide both the orange chips and the purple chips into. It has to be the same for both. How about we take our 4 orange chips, divide them into 4 groups, and same with the purple, divide it into 4 groups. Now I've discovered the same equivalent ratio in lowest terms. The ratio is 1 to 4. And that essentially means that for every 1 orange chip, we have 4 purple chips. Now, just for the sake of comparison, let's record this set as a fraction too. What fraction of the set is orange? Pause the film and discuss. Remember that fractions help us answer the question, how many parts compared to the whole? That means we need to figure out the value of the whole set. After a bit of counting, we discover that the whole set is worth 20 bingo chips, and therefore the fraction of the set that is orange is 4/20. Can we simplify 4/20? But of course. After dividing each part of my fraction into groups of 4, I end up with a much friendlier looking equivalent fraction of 1/5. Time for a ratio field trip. I don't often use part-to-part ratios in my life, but there is one place where I use it constantly. Cooking rice. It is a perfect ratio situation. Remember that ratios describe harmonious relationships between parts. Parts of a rice recipe go like this. For every 1 part rice, add 2 parts water. This is a very handy relationship, or ratio, for me to know. If I would like to make a small amount of perfectly fluffy rice, I just make my parts smaller. It's still 1 part rice and 2 parts water, just smaller parts. If I want to make lots of rice, I have 2 options. Either use bigger parts or make an equivalent ratio. If I want to double the rice, for example, I just need to make sure I also double the water, creating a 2 to 4 equivalent ratio. Pretty handy, right? And now you're going to independently practice recording and simplifying part-to-part ratios. Plus, to keep your fraction skills fresh, make sure you express each set as a fraction in lowest terms as well. Good luck, everyone. Finally, can you think of any real-life uses of ratios other than rice? Have a discussion with your family. Where do they use ratios? Take care, everyone, and we'll see you next time.